So good morning, everyone. My name's Simon Wyatt. I'm a partner at Cundall and a member of the BCO ESG Committee. And today we're going to be doing a webinar on the net zero carbon for beginners. This is part of a series of webinars looking at all of ESG topics, starting with net zero carbon, but moving on to looking at social value and governance and strategy as we go forward. There's going to be a webinar every month for the next 12 months. And this is really just a very high-level introduction to the topic of net zero carbon. If you've been following the BCO for the last couple of years, we've done a number of webinars on net zero carbon when the definitions came out from the UK Green Building Council and in the lead up to COP26. But this is kind of just a refresher of where we are, some updates in terms of a response to COP26, and some new definitions which are emerging as the industry starts to align. And with that in mind, I'm joined today by Simon Sturgis, who's head of the Whole Life Carbon Network and has been instrumental in a lot of the net zero carbon and whole life carbon agenda over the last few years, and is leading the carbon alignment project for LETI to try and get the industry on one common definition for net zero carbon. So good morning, Simon.
Morning.
So, as I said, we're going to give a bit of context going through where we are compared to COP26 last year, what's been happening in terms of the industry, just take a step back in terms of what net zero carbon and carbon emissions mean, both for the built environment and wider. We generally always hone in straight away in the construction industry on generally operational energy and embodied carbon, but it's also relevant to understand where they sit in the wider context of carbon reporting. Then kind of go slightly more detail, looking at whole life and embodied carbon, which Simon will run through, and then finishing up looking at operational energy, which has been kind of the center of net zero carbon for the last few years, but obviously embodied carbon has been rising up the agenda, rightly so, because it's becoming more important as we decarbonize the grid. So just giving a bit of context. So last year, we saw COP26 in Glasgow, where the world governments came together to review their targets. Obviously, after Paris, which was 6 years earlier in 2015, where the governments agreed to limit climate change to 2 degrees with an aspiration of reducing it to 1.5 degrees. Unfortunately, before the agreement, commitments were only around about 3 degrees. We saw some movement during COP26. We saw commitments potentially going down as low as 2.1 degrees, but only policies and actions equating to roughly 2.7 degrees. So people are making a lot of commitment and noises, but they're not backing it up with full policy and action. So there's still quite a policy gap, which all global governments are looking at the moment to see if they can move us down towards that 2 degrees and then hopefully on towards 1.5 degrees. So COP26 was aspirational, but didn't deliver as much as we hoped. And there's still a significant amount of work to do. And when they meet again later this year in Turkey, I believe, there's significantly more work to do in order to get down towards the targets we're looking at. What does this mean? Well, it means that we're still on a trajectory for well above 2 degrees, with a significant emissions gap down to 1.5 degrees globally. We need to take urgent action in order to meet that. The IPCC report, which came out a couple of months ago, was pretty damning, indicating that we need to take drastic action urgently to mitigate the worst effects of climate changes going forward. And we need to take that action in the next kind of 2 to 3 years in order to alleviate the worst effects. What's the UK government doing? Well, the UK government is actually doing reasonably well in terms of commitments, but again, they're lacking policy and focus to deliver those commitments. So Back in 2019, they amended the Climate Change Act to be net zero carbon by 2050, which was originally a target of 80% reduction. Now it's down to 0, which means there's no places to hide. All industries need to decarbonise, both new buildings and existing buildings, and all other sectors of the economy need to move down to net zero carbon by 2050. This is a legally binding target and is fairly aspirational. UK government one of the first to do this. Since then, they've actually brought in some interim targets, because it's not just good enough to be net zero carbon by 2050. If we only achieve it kind of towards the end of the 2040s, we will have spent our carbon budget and be over 2 degrees. We need significant reductions, as I said earlier, before that. So the UK government has tried to align their emission trajectory to a 1.5 degree trajectory. They're not quite there yet, but they're looking at 78% reduction by 2035 and a 68% reduction by 2030, which is what they committed to at COP. These are closely aligned to 1.5 degrees, but not fully aligned. I think there's only one country in the world which is fully aligned at the moment with the 1.5 degree trajectory. There's a dozen or so countries, including the UK, which are considered to be near, but not fully aligned. So what does this actually mean? Well, it means from our 1999 baseline, we need to get down to 0, and we have a number of interim targets on the way. And we're currently in 2022, which means we should have reduced our carbon emissions by just over 50% by now. We're obviously not on track for that, but we are doing well in terms of grid decarbonisation, and some sectors are decarbonising well. But the built environment is significantly lagging behind in terms of its reduction as we go forward. Most new schemes built to kind of regulations and standards are only kind of achieving a kind of 20 to 30% reduction over the 1990 baseline level. So we need significant action on new build, and we need significant action on retrofit and refurbishment as we go forward. And retrofit and refurbishment will become much more important in order to meet those targets as embodied carbon drives up the agenda. So just taking a step back, so what do we actually need to look at, and what do we actually kind of report? So when we're looking at carbon footprinting, we basically have to follow a standard process kind of on an annual basis, which is calculating the carbon footprint, reducing that footprint in, if there's any emissions left, offsetting it. And what's really important is reporting that transparently so that everyone can see that everyone is doing it to the same standard and processes. Seems like a fairly straightforward process, but carbon emissions are a lot more complicated than that. When we talk about carbon emissions, we generally want to refer to the greenhouse gas protocols. So the greenhouse gas protocols define all carbon emissions, all greenhouse gas emissions globally. They don't just cover carbon, they cover all greenhouse gases, and they're broken into 3 scopes. So scope 1 emissions are where you directly burn fossil fuels. So that's things like gas boilers in buildings, also vehicles and fleets of vehicles that are part of a business. Scope 2 emissions, which is indirect use of indirect use of fossil fuels such as electricity, district heating, district cooling. Both of these can be fairly accurately reported and have been done for a number of years. You just take your gas and electricity bill, quantities of diesel that you take, petrol invoices. As a company, those are fairly easy to report, and at building level, it's normally just your gas and electricity bill. But carbon emissions don't just stop there. We also have what are known as scope 3 emissions, which are indirect emissions, both up and downstream emissions, which cover basically everything we touch has a carbon footprint. So business travels, commuting, all goods and services we purchase, any transaction you do will have a carbon footprint, and that should be accounted for at corporate level. When we look at buildings, we generally try and simplify this process. We generally very much focus on the scope 1 and 2 emissions, but we also look at scope 3 in terms of capital goods, so the materials we use to build buildings, transportation of materials to site, and also fuel and energy related activities. And a number of years ago, what we did in the built environment, and Simon was heavily involved in this, was to create something called the life cycle modules, which simplify the scope 3 emission, all scope emissions for the built environment with a focus around Scope 3 embodied carbon and whole life carbon. So I'll hand over to Simon now, who's going to take you through the definition of the life cycle modules and go in a bit more detail on embodied carbon and whole life carbon.
Simon, you need to come out of the
Sorry, there you go.
Okay, so
yeah, we can see that now, Simon.
Great. I hope that looks okay. So thank you, Simon. So it's a bit of a double Simon like this. What I'm going to try and explain, without getting too complicated, is the structure of whole life carbon assessments. And you'll see in the different colors there, it's broken down into, in purple, you've got module A, which is about product sourcing principally and construction. Then in orange, and you've got the module B, which is to do with materials, which is in use, emissions, maintenance, repair, replacement, and so on. And below that, also obviously in use, is operational energy, operational water. And below that is user activities not covered by B1 to B7. So you've got the in use in the middle there, and then the end of life, which is demolition or deconstruction preferably. And all of those together, as you can see in the outer dotted box, represent whole life carbon. So all of that would be described as a whole life carbon assessment. So it's both operational emissions and embodied emissions from the material use. And if you look at this sort of smaller box, the second size box, if you like, which is embodied carbon or oblique life cycle embodied carbon, everything in there, which is material orientated, is what is described as embodied carbon. So it includes not just the upfront carbon, which is the initial carbon expenditure from product and product sourcing and fabrication and so on, and construction, but also it includes in use and end of life. So that gives you your total embodied carbon over the life of a building. You'll see below those, the purple and orange and blue, you'll see biogenic carbon. This is sort of the benefit, carbon benefit from using natural products, timber, and so on, and also includes other sequestration from things like concrete that can absorb carbon dioxide. Now you'll see those are outside of the upfront carbon box. And the reason for that is that you only really count that into your assessment if you're counting A, B, and C all together. Otherwise, you're sort of, if you like, cooking the books if you only included an A. Module D on the right there is beyond building life cycle. So that's after the building's been taken apart and demolished. And what this is about is the potential for reuse, recovery, and recycling of components. So, for example, if you make it easy to deconstruct or disassemble your building, then of course there's a greater value in the future, because of course there's more things that can be recycled and reused on future projects. And of course, the other thing that's worth noting is that in each of the sort of maintenance, repair, replacement modules are effectively a sort of mini version of the whole. So when you, for example, replace a cladding system or something, you're really doing the same thing as a new building, but in microcosm. So I'll just go on to sort of something a bit more about definitions. So this document that Simon mentioned is something that's been worked on by a group, a sort of cross-industry group. And you'll see at the moment there, it's just got Whole Life Carbon Network, it's got LETI and RIBA, but we are at a point where we're just about to add in CIBC, RICS, iStruct, UKGBC, and ICE, subject to their approvals by their professional institutions. And what we're trying to do here is produce a sort of consistent set of definitions for cross-industry use. An early version of this was produced and in fact is available on the LETI website from last May. But this is being updated. And I'm just going to show you a couple of things. So what this is trying to do, and the reason for this is that a lot of different organizations produce their own definitions, which are all slightly conflicted. So what this is trying to do is produce a consistent set of definitions that align with that structure that I've just shown you in all the different colors. So what this is doing, for example, whole life carbon, it's describing, I won't go through these in detail, but it's describing what whole life carbon is. And basically it's saying it's all of those modules as I've described. And then you've got embodied carbon, upfront carbon, which is the early stage, and then operational carbon, which Simon will talk about later. And then I think most importantly is net zero. So typically net zero has been thought of as reducing your in-use, your operational emissions down to zero. Well, in reality, what we're now saying is that net zero is everything, because it is then consistent with science-based targets, and it's consistent with the overall trajectory that Simon was talking about. So again, I'll just read this very quickly, but a net zero carbon asset is one with the sum total of all asset-related greenhouse gas emissions, both operational and embodied, over an asset's life cycle. And all of those there you're looking at are A, B, and C in total are minimized, meet local carbon, energy, and water targets, and with residual offsets equals zero. So the idea is that you maximize your reductions before offsetting. So I'll just take you through each of these stages, just to give you some sort of an idea of the ways you might, a quick sort of snapshot of the ways you might reduce. So these first stages, as I said, are the product and construction stage, module A. And on the left there, you've got actually a cross-section through the new proposed, the new Google headquarters under construction next to King's Cross. And what this is doing is reducing its carbon footprint. I was involved in this by introducing things like intermediate timber floors and then timber cladding on the outside as well. And they're looking, despite all of that, which you might think, well, what about the life expectancy and so on? But they're looking at least 100-year life cycle. The building on the right, some of you might notice, is Triton Square. Number one, I think, is Triton Square in London. And that is actually a retrofit. So what has happened there is that the existing frame has been retained and various other elements have been retained, but it is fundamentally a retrofit in practice, but it feels and looks and operates like a new building. So that, of course, has a much lower footprint. Both of those are different ways of lowering your footprint. Also important is something like, and I'm using sort of aluminium as an example here, that if you, and this is not a hard and fast rule, but as a general principle, if you're using, say, anodizing, well, of course, you need a consistent substrate to aluminium, which means you need new aluminium to ensure the color is consistent across your entire facade. Whereas if you use recycled aluminium, then you're going to need powder coating. But so in other words, if you choose powder coating rather than anodizing, you're able to use recycled material. There are other issues, for example, like life expectancy and so on, to take into consideration. This is to do with the use phase. So what this is really saying is that the facade on the left, which is obviously a brick facade, has a very long life. Obviously, windows might need to be replaced from time to time, but fundamentally, the majority of the facade is a long life facade. The facade on the right, which some of you might recognize, I'm not going to mention where it is. It's in London. I'm not going to mention who did it, but that one is a complex triple glazed facade. And the reason it's with a cavity, so the reason it's a triple glazed unitized system is because it is trying to combat the heat of the sun and therefore minimize air conditioning costs. So that the trajectory for, an intention for this facade is to reduce operational energy, which is a good thing. However, a facade like this, the double glazed units and the seals around these units tend not to last more than 30, 40 years max. So facades like this tend to have to be replaced on a fairly regular basis. And a building of this size, you'd expect to last maybe 100 plus years. And the Empire State Building, I think, is 90-something years old. So, is it logical, either economically, or certainly climate and carbon terms, to have a design which encourages replacement, 2 or 3 times over its life cycle? So in use operational energy and water, this is really just making the point that obviously you can manage the amount of energy you use within a building on how you design the facade on the right there, and obviously how you can deal with the temperature and so on inside, humidity and what have you, can all be managed by fabric, if you like, a fabric first type of approach. Then end of life stage. So this is actually, this is the building I was involved with, it belongs to Segro. And what we did was we actually dismantled the building and moved it about 2 miles to a new site, which is commercially much more attractive. So that's the photograph before, and that's also the photograph after, if you like. So module D, reuse, recovery, cycling. Now, the interesting thing about that was it was to do that, it was cheaper, it used less material, and it was quicker on site. So, and of course, this is a fairly typical 2-story industrial unit with a couple of double height space mostly, but with a 2-story office section at the back. And we, as I say, we were able to reuse something like 70% of that building in moving it. And of course, the costs, I think, were about 25% down. So what about costs? So this again is the Google building. What we found with virtually every single tender is that the cost, the carbon cost of the lowest and the lowest tender price coincided in almost every case, as I say. So that was really quite encouraging. This is actually a residential building, but the same basic principle. This was a Quintain project we were advising on, but we were advising, for example, going from 850 down there to 506 as the possible menu of options. And the Quantity Surveyor said that those sort of reductions of those 75% of them were certainly cost neutral, and the other 25% was worth tendering anyway. So if you look at the column on the left, that is, if you like, the build-up of the carbon impacts of a new office building over 60 years. So you've got energy, interior fit-outs, cladding, and so on, building up to make that. Now, the experience that I've had with many developers is that it is possible to get 20 to 30% carbon reduction against that total picture with current supply chain and being cost neutral at the same time. So there's nothing difficult or weird about trying to get that level of reductions, and that would be compared to, say, 1990 levels. Obviously, the next sort of 20 to 30% is more difficult, and you start having to do more innovation, or as Simon mentioned, starting to introduce a bit more retrofit. And then as we go forward towards 2035, of course, we need a greater level of innovation and so on. So the first bit is not that difficult and is achievable right now. And certainly with developers such as British Land, Landsec and others, we were achieving those kind of reductions without any problem. And certainly they weren't enthusiastic about spending extra money on carbon reduction, and no discredit to them on that. So this is defined, if you like, by, or this is produced by LETI. And this is what they've done is a sort of a bit like an EPC, a sort of colored grading for to illustrate the reductions that are required. So if you look at the solid curve, that gives you an idea of more or less where we are today and where the predominance of projects coming out are in that sort of red zone, sort of under E. And where we need to get to within 8 years is, within 8 at the bottom there, but the average would be by 2035 is the A, which is that sort of lime green, which sort of again links up with that trajectory that Simon was showing you. And in terms of office, you can see in terms of numbers, if we're sort of the average around 2020, 2021 is over 1,000 there, about 1180 or thereabouts, we need to be below half that by 2035. So that gives you some idea of the kind of scale of change that needs to kind of come in and achieve those sorts of reductions. And what this diagram here is, this is a life cycle picture. So what you're looking at here is a graph where on the left, you've got on the extreme left, PC at the bottom left there, you've got the construction emissions, and then each of those spikes represents, as you go from left to right, represents replacements and so on. And you can see overlaid with that in blue are the sort of lease events, and then in sort of grading up in yellow would represent climate change. So the objective here is to try and align lease events, if you like, with the efficiency of which the building is managed and operated, so that instead of having your, in this case, we've got major changes that look like they need to be happen just before a second lease event. And of course, that would be very inefficient because the building is going to mean cost. It's going to be, you can be struggling on for 5 years or so with the building system starting to fail and what have you. So, it's how do we optimize the efficiency of those sorts of things. This diagram here, this is actually a residential block, but the same sort of thing would apply to an office building, with the exception that the blue columns would be slightly higher. So what you're looking at here, and this is a sort of a map, if you like, aggregated map every 5 years of the carbon emissions of a project. So on the left there, you've got construction emissions in dark green. And then at the bottom, you can just see a little emerging bit of operational energy in blue. And then that's obviously going up, aggregating up year off every 5 years. And then you're starting to get in pale green, you're starting to get the sort of repair and maintenance emissions, which are also aggregating up. Obviously, the construction emissions stay static because you've built it at the outset, but it gives you an idea of how things change and why embodied emissions are important over the first half of a building's life, particularly, and the construction emissions are particularly important. So just a couple of points. These aren't office related, but they kind of give you an idea. So one of the things about future-proofing a building is to talk about durability, adaptability, and flexibility. And you can see here a Victorian terrace house is a pretty standard example of that kind of thing. This one here, these are both two design museums. The one on the left is clearly incapable of being used for anything else other than a design museum, I would imagine. The one on the right is, of course, capable of being used for different things, and I think it's now offices. So that gives you an idea of the sort of thought processes that obviously very weird things are problematic. I've already mentioned facades. This is pretty much the same story, so I won't go through that one again. And then here we've got obviously materials, assembly, modularity, and disassembly, and how all those sort of things can be optimized to ensure that there isn't future wastage. And of course, the advantages of assembling things in a factory mean that you've got a tighter control over the conditions in which things are made. This is a point really about U value, that typically when we think about insulation, we think about it as only providing a U value, in other words, an energy performance enhancement value. But what this is saying is that the material itself has a carbon cost. The one on the left is about, I think it's about 10 times the carbon footprint of the one on the right. But then you've got to think about life cycle. Will the one on the right last as long, and so on and so forth? So you need to balance out these things and think holistically about this. This is a pretty simple example of shape, heat loss form factor, or wall to floor ratio. I think it's pretty self-evident that complicated shapes have all sorts of issues when it comes to operational and embodied emissions. And this is Everyman Theatre, which is completely naturally ventilated. And so what you're doing is you're trading off, for example, on the top there, some brick cooling towers for the embodied carbon costs of those. In fact, they're made out of recycled bricks from the site. But that sort of thing you're trading off against plant, which obviously, and of course, plant needs to be replaced every 20, 25 years or thereabouts. So you've got these, again, you've got these life cycle costs versus initial costs. So I thought I'd just run quickly through the business case, if you like, for doing whole life carbon assessments and really looking at this sort of thing holistically. So one of the first ones is it is ultimately about improving resource efficiency. And of course, that includes money. And so it is really part of, or should be part of value engineering. You know, what is the carbon efficiency of the building? Are we using materials to their optimum? There's obviously life cycle issues, which is to do with future performance and future cash flow. You can obviously, if you do like that graph I showed you with the spikes on it, if you do one of those, you can actually start to predict when things are likely to fail, does that all make sense? And you can put a cash flow to it. Certainly with the Google building, they were interested in putting a cash flow to the whole of that. And so you get an idea of the total cost of ownership as opposed to just the construction cost. Life cycle is also about durability, adaptability, and of course that is starting to come into due diligence with a number of developers I've spoken about the idea of when they purchase a recently built asset, they will start to be asking for a whole life cycle, whole life carbon assessment to understand how the building is expected to perform going forward. There's also potential insurance benefits. You can demonstrate that, you know, that there is durability associated with the building. So it's likely to fail, then that can have certainly benefits. Also potential marketing benefits. I think my belief, and certainly I think starting to happen, that certainly investors, I think, are starting to take an interest in, if you like, greener development. And also, of course, tenants will start to take a bigger interest in this. I think buildings that don't respond to these things will start to have problems, I think, in terms of value and attracting tenants. So this is about future-proofing asset value, climate ready, climate clean. Also, I think by acting now, you're also preempting future regulations. And as I mentioned, tenant demand, which is always a good thing if you don't have to go too far. And also, as I said, if it can be cost neutral. You're contributing to BREEAM. There's typically a whole life carbon assessment is producing a whole raft of information that would contribute to a BREEAM assessment. You're also obviously contributing to your environmental impact assessment at planning stage. And there's obviously something to be said for improving your own ESG image. Thank you very much.
Thank you, Simon. Just share my screen again. Okay. So as Simon indicated, operational energy is part of the whole life carbon assessment and has generally been the main focus of the industry over the last 2 decades, but obviously the upfront embodied carbon now is the predominant carbon footprint of a building, especially with grid decarbonisation. It could be as high as kind of 60, 70, even up to 80% of certain types of buildings, but it still means we still have to look at operational energy and reduce that as much as possible. So as Simon indicated, there are new definitions for net zero carbon. And in terms of operational energy, a net zero carbon asset is one where no fossil fuels are used on site. All energy use has been minimalised. It meets local intensity targets, and all energy used on site, all energy comes from on or off site renewables to demonstrate additionality. So if we look at the diagram here, the kind of focus is moving away from natural gas for heating, cooling, heating, domestic hot water, cooking, moving to all electric systems, then reducing the energy consumption of those electric systems, providing that energy. Yeah.
There's a message to say the screen's not being shared.
Sorry. Can you see that now, Simon?
Yes, yes.
Apologies. So as I was saying, that the main focus is to remove fossil fuels. So for new buildings, that's fairly easy. It's going to things like heat pumps for heating, CO2 heat pumps for domestic hot water, induction hobs for cooking. Then it's about reducing your electrical consumption by energy efficiency, fabric first approach. And then once you've reduced it as low as possible, it's providing as much energy on site as possible. And where that's not possible, things like city centre locations, then it's procuring green energy. There'll always be some scope 1 emissions left, generally associated with things like refrigerant and emergency power, and they will need to be offset to move down to zero. So one of the key targets or requirements, as I said, was to meet intensity targets. And at the moment, the industry has been developing a raft of carbon intensity targets, operational energy intensity targets, like the embodied carbon ones. And the way that they've done this is twofold. One is to produce what are known as Paris-proof targets, which is looking at current consumption rates and looking at the level of reduction required, whether that is practical, but saying where we need to achieve. And then there's a bottom-up approach, which is looking at what is theoretically practical, and both are kind of getting to the same level. But if you generally think about the UK going to all electric, we're going to be putting all of our heating onto electric, all of our cars onto electric. There's going to be a significant increase in demand. And in order to move to a net zero carbon economy, we must produce all of that electricity from renewables. And there's two ways we're going to do that as a country. One is to increase the amount of renewables, which we've been doing very well. I think last week, 85% of our energy came from wind and hydro and solar, and only 15% generally from coal. So we're moving in the right direction, and there's plans to put more capacity onto the grid as we go forward. But there's only so much capacity we have. What we need to do is at the same time reduce the amount of energy we use from all sectors. And that reduction roughly equates to about a 60% reduction in energy usage in order to meet all of our energy from renewable sources. So what the built environment has done is it's set some targets. So LETI, UK GBC, and other institutes are setting intensity targets for buildings. So you can see here for the office sector that a typical office building in the UK will use around about 300 kilowatt hours, with the best practice 25% being just below 200. In order to be Paris-proof aligned, we want to be down kind of at 70 kilowatt hours per metre squared. And what the UK Green Building Council has done is it's produced a step trajectory. So basically, every 5 years, they've ratcheted down these targets as we go forward and given targets for a whole building. So looking at all the metered electricity usage within that building, but then broken that down to base building and tenant energy consumption. So base building would be things like the ventilation, the heating, the cooling, the landlord lighting, whereas the tenant energy consumption would be the tenant lighting and small power consumptions. There's separate targets because the design team will very much focus on the base build because that's what they can affect, but then work with behavior change and tenant engagement to reduce the tenancy. And as of last year, there was a rating system launched called Neighbours, which has come over from Australia, which looks at the base building and can certify it to a star level based on its operational performance. What's really important to understand about Neighbours is it is an operational standard. So you can do design calculations and predictions to predict a rating, but what really matters is that in-use performance. So we're not looking at predictions and calculations, we're looking at actual meter readings to see how the buildings are performing in use, which is something we haven't really done in the UK. And at the moment, a lot of landlords are looking at their portfolios and they're generally only achieving kind of 1 or 2 star, whereas the new buildings that they're designing, they're aiming kind of for the 5 or 6 star, but that's a significant step change from where we have been in the UK for the last decade or so. And what we're having to do in order to get to that level of reduction is really at the design stage, look at detailed analysis to predict or estimate the operational energy consumption. And there are a number of methodologies for doing so. So in simple buildings like dwellings or basic offices which have minimal HVAC systems, then the passive house tool is a very proven technology for predicting operational energy consumption and achieving it in use. For more simple buildings which aren't heat-led, CIBC TM54 is a good tool of predicting operational energy. But the main one we're seeing in the office sector at the moment is Design for Performance, which is doing detailed HVAC modeling of all systems within a building, using actual performance profiles of the building, looking at every single hour of the year, how plant operates and works going forward. What it's not is it's not looking at the building regulations, Part L calculations or EPC calculations. They're not estimates of energy consumption. They're looking at energy efficiency only. So they're looking at how efficient a light fitting is, not how long you use the light fitting or how many light fittings you have. And it only looks at a certain percentage of the energy. It only looks at what's known as regulated loads. So it only looks at things like heating, cooling, ventilation. It doesn't look at things like plug-in process loads, small power, lifts. So it only accounts for generally about 50% of the energy of a building, and it doesn't model it with the actual operational performance. So we need to be using Design for Performance, Passive House or CIBC TM54 to do those predictions, to have any hope of actually achieving those performances in use. What's interesting though about operational energy compared to upfront embodied carbon is the upfront embodied carbon, as Simon showed, is spent on practical completion. So you build the building, it's a one-off carbon assessment. It's the biggest carbon impact of that building, but it's generally built and then forgotten about. Whereas the operational energy is is reported on a yearly basis. And obviously, if we're working to a trajectory or stepped agreement, then that will need annual performance improvements. So what's been released is something called CRREM, which has come from the European investment banks, and science-based targets, which are corporate targets for reducing energy consumption. And they've set out some targets for assets, existing assets, and obviously any new building that's built, as soon as it becomes operational, becomes an existing asset. And with an existing asset, you can plot the performance of that asset against the Paris proof 1.5 degree trajectory. And you can see here that this asset is below the green line and is therefore aligned to the Paris Agreement and is performing well. But if it doesn't do any retrofit or refurbishment works as we go forward in time, its performance will be the same and the target will reduce. And it will become what is known as stranded, which basically means it's no longer aligned to the Paris Agreement and might be subject to financial implications in terms of being able to sell the asset, let the asset, and also regulatory requirements as the UK government tries to hit its 2050 targets. So if a building is being built to the UK GBC step trajectories, which we showed earlier, then it's not aligned to the Paris Agreement, it's an interim step, then it will eventually strand. So it might be net zero carbon on day one, but after kind of 6 to 7 years, it will become a stranded asset, just the same as any existing building, unless retrofit works are undertaken. So what a lot of existing portfolios and a lot of existing office buildings are doing at the moment is looking at their current performance, looking at interventions that can be done to move that stranding date out in order to avoid that stranding event. Why is this important? Well, when we're looking at new buildings, there's quite a lot of discussion around the cost of net zero carbon. There's been a number of reports, including by the UK GBC, indicating kind of a 5 to 20% uplift for net zero carbon. And if you think about a typical building, if you're building a building and you have a cost, and then there's the cost of getting it to align with the Paris Agreement, that might be kind of 5 or 10%. You can spend that at day one, but if you don't spend that at day one, that building will still need to be net zero carbon in the future. So if you're planning on selling that asset, that you might think that's fine, but investors like Aviva, Legal and General, will be doing technical due diligence on any building they're acquiring at the moment to look at what the cost of moving that to net zero carbon will be, to look at the cost appraisal. So you either spend it now or we're going to have to spend it later. And obviously the cost of recladding or doing significant works to a building is going to be much more at year 10 than it would be in today's market. So if we're looking at whole life carbon, we should also be looking at whole life costing to understand the actual cost of going to net zero carbon and when those interventions should be done. And it generally indicates that it's generally much more expensive to work to minimum standards and then try and uplift it at later stages. And what most clients are looking at the moment is making sure that they get a fabric first approach, because if you're not hitting net zero carbon on day one, what you definitely don't want to do is have to go back and do significant works to the fabric. If you're just shy of the net zero carbon Paris proof target, and you can do things to your on-floor plants, you can change your lighting, you can improve your ICT. They're things which are done kind of on a 3, 5 and 10-year cycle, whereas what you don't want to do is have to upgrade the fabric after 10 years on a new building or even 20 years. What we want to do is make sure that fabric is correct from the beginning and potentially spend a little bit extra there to safeguard and future-proof the building against upcoming standard requirements. Again, as I said, it's not just new buildings. I've got a couple of case studies. So this is what a lot of landlords are doing at the moment. They're going in and doing reviews of their existing buildings. And when we do a review of the existing buildings, we break it down into elemental steps. So we look at things like passive design, operational energy, emitting fossil fuels, renewable energy, a little bit around the upfront and whole life carbon, and kind of score the performance of an asset from green to red and try and move everything over to the green by improving the individual elements of the building fabric, the systems, removing fossil fuels, as we've said earlier, moving to heat pumps, induction hobs. So a lot of buildings at the moment might be at over 220 kilowatt hours, and they're aiming to get down to the LETI target of 55. And in order to do that, they need to produce a pathway looking at introducing things like heat pumps, improving fabric, looking at natural ventilation, optimizing plant, but also a significant focus on behavior change in the occupants. As I said, they can make up over 50% of the energy. So in order to get down to the lower levels, we need to change the behavior of the occupiers and have occupier behavior change, leases into the requirements, and move that operational energy performance. And with existing assets, it's not as simple as doing this in one hit. What we need to do is phase that into a program over time, depending on sitting tenants, when you get spaces back, when you have planned plant maintenance and refurbishment. And then again, we can plot that against those trajectories so we can have the current performance and look at those individual interventions and what that will do to our stranding points. And because it's not an exact science, there will be some range and tolerance as we go forward with the individual measures going forward. And as I said, this needs to be programmed in over the life of the building. And if you've just signed a tenant to a new building for a 20-year lease, it means that you're not going to probably be able to get into that space for 20 years, and you're going to struggle to make that building net zero carbon before 2030. You might even struggle to get it to net zero carbon in operation by 2040 if you've only just taken tenants with a long lease. So in terms of new buildings, this is a building I'm working on in Manchester, which is in Salford. It's called Eden, and it's looking to be BREEAM outstanding. It's doing design for performance with the aspiration of becoming the Neighbours 5.5 star, which would be the joint highest rated Neighbours building in the country if it achieves that level. As I said, Neighbours looks at just the base building consumption. So it looks at the whole building HVAC systems, lifts, common area lighting and power, and hot water. What it doesn't cover is the occupier, lighting, small power. Again, we need to add that in when we're looking at whole buildings and understand that and have a route to net zero carbon for that. But as a design team, the only thing that we can be certain on or have a large amount of control over will be the base building systems. So as I said, the A3 is aiming for the 2035 step. So it's not fully Paris aligned. There's no buildings at the moment in the UK, office buildings that I'm aware of, they're actually achieving that 6-star Neighbours or the Paris aligned 55. Most of the best practice are generally at that 5-star and significantly above the LETI UK GBC Paris proof target. Again, aiming for that base build is what we're looking at the moment. So in terms of the design of that building, what's been done to it is the main focus has been on the fabric first. So it's got really good air tightness and U values. It's reduced the glazing down to less than 40% ratio, 60% solid with a high performing facade system. All the insulation is pretty much to passive house standard. And as I said, the air tightness is down to 2 compared to building regulations 10. It's combustion free, so it's an all electric building using heat pumps to do the heating, with CO2 heat pumps providing high efficiency hot water. And it's also relaxed set points, so we don't have simultaneous heating and cooling. We're heating only to 20, cooling down to 25, and also looking at significantly reduced internal loads, much smaller equipment operating more efficiently, looking at the efficiency of every piece of equipment in the building. And as you can see, it's still above the Paris proof target, but it's getting closer. And a large amount of that is down to tenant energy consumption if we look at the entire building. Whereas if we just look at the split, so the UK GBC target is 35 for the base building, 35 for the landlord. 35 for the landlord, 35 for the tenant. And we can see that the landlord systems are coming in close to that Paris aligned target, just over it, whereas we're expecting the tenants to be significantly above that. So what we've done going forward, and this is what we recommend for all buildings, is it will be net zero carbon up until 2035, and then it will be stranded like any other asset. So what we've done is put a pathway in how we reduce it from the current standard to the final steps, which will be minor plant replacement, and then how we can work with tenants to reduce their 60 down to the 35 over the next kind of 10 years with tenant behavior requirements and leasing requirements. Okay, so that's the end of the presentation. Do we have any questions? If you've got any questions, write them in the chat. There's a couple already come in, so I'll read those out and we'll go from there. Simon, this one's aimed at you, which is to do with 22 Bishopsgate, which was one of the examples you showed, which was showing a significant improvement over the LETI benchmark target, but has a facade which needs replacing fairly regularly. So he's asking, is that greenwash?
Well, I think that's my suspicion is that 591 figure is for upfront emissions only. So it's almost certainly carefully left out the replacements of that facade and indeed replaced with anything else. So in a sense, whether that's true or not, and it looks extraordinarily low anyway, but still, assuming it's true, then I think what they've done is obviously only used part of the story. This is something that I have discussed with LETI, because what is happening is that in a number of cases, people are sort of selectively using reporting of and how they do assessments to produce obviously the best possible looking outcome, but it's actually not the whole story. And I guess that's what's happened here.
Yeah, and I think to be honest, with the LETI consistency project, with no targets for both the upfront and whole life carbon, then if you're scoring well on one and not scoring well on the other, you're going to be found out. So you need to be looking at both that. A1 to A5 is important now because that's where we're in the climate emergency, but you still need to be looking at the full A to D modules and achieving a good score against the whole life carbon targets. There's another.
I was going to say one other thing on that. I mean, what is interesting is that the previous mayor of New York, Bill de Blasio, was threatening to ban all glass buildings on exactly these grounds. So I think, again, there's a sort of an image thing that's probably going to start kicking in here as well.
That leads us nicely on to the next question, which is what punishments are in place should legally binding 2050 net zero carbon not be met? I'll cover that for operational energy, then I'll go to Simon for embodied carbon. So in terms of operational energy, it's interesting because last year the government consulted on mandatory energy performance requirements for buildings. So at the moment, most energy performance requirements are dealt with by the building regulations, which looks at a building before it's built and in operation. So they're proposing for the first time ever to look at the actual performance of buildings and require them to disclose it. And the idea is that we start with commercial offices. So the idea is to start with, it would be that every commercial office over a certain size will have to publicly disclose their energy performance on an annual basis. So that would be the gas and electricity bills. What that will do will be two things. One, it will start having a league table of offices. So offices will be league tabled, and like the University Green League, no one will want to be near the bottom. So there's a lot of reputational risk associated with poor performing buildings. But what I expect will happen is because the government's 2050 target is legally binding, they will start putting financial penalties at a certain point, which will ratchet up. So they basically have a red line on that table, and anyone below it will be fined, and anyone above that will be fine. But like we saw with EPCs, ESOS, and other energy schemes, those fines have been fairly small and marginal and not really hit any companies. I think the reputational risk is much bigger, especially with the focus on ESG for most funds. And investment funds. So most investment funds that I advise at the moment are setting ESG and net zero carbon requirements. And if you do not meet those requirements, you do not have access to funding. And that's becoming more and more stringent going forward. So I don't expect the government's fines and penalties to be significant, and they're probably behind the market. But I'd be very concerned about being able to raise capital if you're not meeting some of these targets in the future. Simon, what's your thoughts on embodied carbon? Because it's much harder because obviously once the upfront embodied carbon spent, it's spent.
Yeah, I think the answer is none at the moment. But I think that's probably because the whole world, if you like, of embodied carbon has only recently been sort of an issue of consideration. That being said, though, I think that is starting to change. And certainly, I mean, one of the things I'm involved with is I'm a special advisor to the Environmental Audit Select Committee, and they've been running a inquiry on whole life carbon. The report on that will be coming out in a few weeks, which will be worth looking at. But in that, and I can't obviously say too much about it until it's published, but in essence, that will, I think, increase awareness of these things across government departments and so on. I think you'll start to see hopefully the government departments will start to lead by example. Already they are supposed to be doing that, but obviously they're not. So I think it comes back to the point that Simon made about reputation. I think this is where this will be more important and more persuasive to people. And some of the stuff I put in the sort of the business case in my presentation was really around those kinds of things that people will start to think about when they're buying an asset. You know, what is its carbon footprint? Is this part of the due diligence when they buy it? And you know, are tenants going to be concerned about what sort of building they're in? And I think with, you know, younger employees, they are starting to be concerned about these issues, and I think that will start to kick in, you know, into retaining staff and things like that. So although these are all very peripheral, I think they will start to make a difference.
I think probably one of the most interesting things we've seen in the last kind of 6 months has been the focus around embodied carbon at planning. So we obviously, Simon and I both worked together on the London Plan's requirement to do whole life carbon assessments. But in the media, we've obviously seen the reaction to the TULIP and also now the M&S scheme that's going through planning. Where do you think that's going, Simon, in terms of regulation and local authorities' requirements for embodied carbon and retrofit?
Well, I think it's an interesting point there. I think the question, which it's now obviously gone to the Secretary of State, Michael Gove, who's sort of not called it in exactly. He's paused it while he thinks about it. But the issue there is that is whether the government is going to stay with what they are familiar with. In other words, business as usual, and allowing the building to be demolished based on current practice and so on, or whether they're going to go with their net zero trajectory, which is the diagram that Simon showed you at the beginning, the downward trajectory. And if they decide to go with that, well, then they will, I would guess they would have to reject it. So it's going to be interesting to see which way they go.
Great. The last question, it's quite an interesting one that's just come in. Which is, it seems a large proportion of problems are tenant energy use. Are there any standards guidance on energy use that landlords can include or enforce as part of a lease agreement? What should be the key improvements that are made by tenants to reduce their annual usage? It's a great question, and it's very true. Like as we showed, that going forward, the tenant energy consumption in offices will be kind of probably up to 50%, if not more than 50% of the energy consumption. I'm doing quite a lot of work in light industrial where it's 100%. And what's interesting is that most landlords and investors have made net zero carbon commitments, which includes their scope 3 tenant energy emissions. So they've signed commitments and requirements to achieve reductions on their tenant energy consumption. And the only way of doing that is stick and carrot. So obviously there's a behavior change process. So occupant engagement, behavior change, education. I think that most landlords are starting to do that and put programs in place, but that will only go so far. And the ultimate way to get down will be through leases. What they do in Australia, where Neighbours came from, is there's a Neighbours base building rating, but there's also a tenant Neighbours rating. And part of the lease is that in order to stay in the building, the occupier must achieve a Neighbours occupier rating. You can set targets in terms of operational energy for a tenant. There is guidance that's being developed at the moment by both the BCO and by the Better Building Partnership on how to engage and set requirements for occupiers. At the moment, the UK market is fairly conservative about this, and most projects are setting green guide requirements rather than lease. But within the next few years, we're definitely going to see more and more leases putting the requirements on tenants. And again, we work with lots of tenants who don't understand that they are such a significant impact. They want the building to be net zero carbon, but when you ask them what they're going to do, like, are they going to operate it only in standard hours? What they're going to do in out of hours operation? What they're going to do in terms of their catering provision? Because you can have a really low energy building, and then as soon as they put a kitchen in to do catering, you're going to blow your carbon allowance pretty quickly. So tenants really need to be thinking about this, and occupiers need to give them much more guidance. At the moment, Simon and I are both working for the BCO, looking at the new fit-out guide, and there'll be more guidance in there for occupiers on how they can move towards net zero carbon, both in terms of the embodied carbon for the fit-out, but also the operational energy. Simon, anything to add on that?
No, that's all good.
Okay, so I think we're going to wrap up there. It's 12 o'clock. I just want to leave it that, as I said, this is part of a BCO ESG webinar series. This was very much just an introduction to net zero carbon. The next one is next month, and that's going to be a much more detailed look at whole life carbon and embodied carbon and what we can do to reduce that in commercial office buildings. So thank you, Simon, for joining us, and thank you all for listening.
Thank you.
Bye.